the advanced technologies and kind of centered around SQL Spatial or Spatial SQL. I'll use that interchangeably throughout the course. I think I learned it wrong the first way, and it's a hard habit to break. But so I wanted to share my screen real quick and jump into it. All right, should be good. So, sure. Like Kurt said, I am the manager of Jonah Energy GIS department. We are a two-man team that lives inside the IT department at Jonah. And before I get into anything SQL Spatial related, I want to give you a little bit of background on myself, just to kind of provide some insight about how I got to where I am now and how I came around to using SQL. I definitely did not start out as a SQL developer by trade or by training, but picked everything up along the way. So, yeah, so whenever I started, I was pretty much entry-level cartographic production technician at Fidelity EMP, and now defunct company that was in Denver. I started my career there and did a lot of really just simple GIS analyst stuff, dipped my toe into a little bit of simple Python development. Then moved to a civil engineering firm, did a lot more cartographic production, simple map making, started to get into a little bit of open source spatial technology, web development, and Python web scraping. Then moving on to Jonah Energy, I started here as an analyst and was kind of the GIS land liaison, again, doing a lot of carto production, but started to take some of the skills that I learned from my previous experience at the civil engineering firm and started to develop more in Python, create more solutions for the land department that they might see beneficial, whether that be web maps or scraping or automation or SQL ETL processes that I've developed over the years. But one of the core beliefs I kind of try and instill in our department is say yes and figure out how to do it later, where it hasn't really come back to bite me yet. But and agile project management, which is a buzzword that people always like to say, but it's kind of the truth. We want to get something in the hands of the users and have like an iterative discussion about how it can be improved, as opposed to perfecting something over months and months and then pushing it out and not getting the data in the hands of the people as quickly as possible. So with that, I'll jump into Spatial SQL. So GIS data in theory is just really shapes on a coordinate plane. I'm thinking back to like 7th grade algebra, whenever you're plotting 0, 0, and 2, 2 on your plane and you're drawing a line and calculating the distance. That's basically all GIS data is. So why can't SQL help visualize that? Microsoft added support for this in 2008, and among other types, they can handle geometry and geography data types. I've only found the use for geometry at this point, which is basically on a flat coordinate plane, as opposed to geography, which takes into account the curvature of the Earth. So if you're really trying to look at flight lines, let's say from London to LA, and you really need to calculate distance based on the curvature of the Earth, that might be something that you would find useful. But for our localized data sets, we really only need to deal with geometry. You can plot points, lines, and polygons all in your SQL Server Management Studio, any of them of choice, and you can perform spatial joins, which I'll get into in a bit, and calculate a lot of things all in SQL without having to get into a GIS GUI in some cases, as opposed to doing spatial joins in Esri environments or QGIS environments like QGIS or ArcMap or GIS Pro. It's a whole lot faster. You can handle it without actually opening an application and getting into some proprietary software. And we handle a lot of really business critical GIS calculations of Jonah Energy, and I'll give some of those examples in a bit. So a lot of you may already know this, but I wanted to give a bare bones explanation about the difference between like a traditional SQL join versus a spatial join. On the left here is a traditional left join that we're doing in SQL, where you're just selecting everything from table 1, anything that coincides with it on table 2 based on a unique key, in this case, FK from table 1 and ID from table 2. It's going to join everything and give you a resulting data set. And that's all obviously tabular data. So the difference between traditional and spatial is on the right. If you visualize the A, B, and C parcels, a spatial join will assign a value to all of those points. I'm thinking of those as wells, since obviously in an E&P company, those wells will all get values of the parcels that they coincide in, and the wells that do not coincide with those parcels or lay on top of them will all get null values. So just to give background on kind of the playground that we're working on. So in general, just to generate some very simple SQL spatial, you can generate a point from raw coordinates. And this is helpful for us as we deal with backend databases that have a lot of data like a well, right, with the latitude and longitude that comes from our data warehouse. We can select a geometry right alongside the rest of the fields that we're going to select in that SQL statement. So if we're selecting fields A and B, we're also going to do some calculation using this function of SQL Spatial as a shape field from a certain table. So what this means right here is you're trying to create a geometry from text, a point geometry, and you're doing some string concatenation here to combine your longitude and your latitude, X and Y. And then you need to define your EPSG code, which is basically your projection or coordinate system. I had to look up what EPSG meant this morning. It is European Petroleum Survey Group. It's an initial code that they created to try and reference all of the different projections and coordinate systems across the Earth. And now it basically just stands for SRIV, or so, like Spatial Reference Identifier. I don't necessarily believe EPSG is European Petroleum is what people identify this as. But for our example, 4269 is North American data in 1983. Which is pretty standard for the work that we do here at Gemini. And the output that shape field is going to create is a hexadecimal code, which corresponds to a location on the Earth. So whenever you select this A field, B field, and shape field, this is what your shape is going to look like if you have a longitude and latitude. Those strings can get pretty long, especially if you have circles or complex polygons. That hexadecimal code can get very long. Now, generating some line string data from raw coordinates, you can also do the same thing. You just have to have, obviously, two coordinates, like I was talking about in my 7th grade algebra example. You create this geometry from the text. You do some concatenation by combining your latitude and longitude from your first point and your X and Y from your second point. Again, defining your EPSG code as your shape, and that will output you a line coordinate in your SQL Server Management Studio spatial results window. So creating a spatial join between polygons and points. I'm going to try and switch which screen that I'm sharing here, so I can actually get this code. That's the wrong one. Okay. So now I want to jump into some code and just give you the most basic example that I can pretty much think of, which is basically just creating some points and some circles and trying to do a spatial join right now in SQL. So to start, we're going to declare some variables as geometries and we're going to call them A and B, and we're going to set those geometries in the same way that we had previously done this stgeom from text function, define our coordinates, and I picked those coordinates because if they look familiar, they are basically Denver, and I defined our datum as NAT83 as I was explaining before. So we're going to select point A and point B into a temporary table right here and define this A field as our shape and this B field as our shape. So we'll go ahead and run this. I didn't drop my tables. So I'm going to go ahead and run this, and you can see if we select all the things from point, we now have 2 points in our database corresponding to point A and its geometry and point B and its geometry into our points table. So I'll get into this in a bit. Let's comment that out. But now I want to select some circles into a different table that I'm going to call area as a temporary table. So using the same geometry that I used for A and B, I'm going to use a SQL spatial function called buffer with tolerance that I'm going to create a buffer around our 2 points, and which will create a circle, obviously. The first field here is the distance that I want to use, and this will correspond always to the projection or the EPSG code that you're using. I'm using latitudes and longitudes, so this one will correspond to a literal degree on the Earth. So it'll be pretty big. These last two are tolerance and relative. Relative, the last one is a 1 or 0. It's a yes or no. I haven't found the need to change those yet. If anyone wants to educate me on why I should or shouldn't, I'm all ears. But I'm going to select these 2 points, or sorry, yeah, these 2 points and their subsequent circles into our area table. So if I select star from area, basically I'm just going to select these 2 circles that we just created. I'm going to end up with our area A and area B and their hexadecimal code, which, like I was talking about with the circle, it goes on forever. So some of these crazy advanced polygon shapes can really have extensive shape fields, but I'll open the shape result. We can see our 2 fields, or these 2 circles right here, one for -104.40 as we generated, and one for 39, -105. So I'm now going to do real simple spatial join using the contains feature. So I'm basically going to join our points to our area based on shape. So if the circle contains one of the points, it is going to assign the area ID to that resulting point. So I'll run this, and as you can see, point A corresponds to area A. I hope it does, because it's literally the center point of the circle, and point B corresponds to area B. So that's very simply our first spatial join, probably the most basic example I can think of. And you might be asking, what if a point coincides to both circles? So I'm going to uncomment this right here and throw in a point C, which is going to use a geometry that should be right in the middle of those 2. So now when I do the spatial join, we should see some additional data for point C. And as you can see, point C being right in the middle, it corresponds to area A and area B. And if you want to get into further, different types of joins, you can only allow it to have one join, but for this, since it's in the middle, it's going to join to area A and area B. Let's jump back over to my PowerPoint. Okay. So now another thing I want to talk about is spatial indexing, which we found to be critical to any time that we want to join large data sets. So like many of you probably know, I don't come from a SQL background, obviously, like I've said, so this is all very new to me, but generating primary key constraints and spatial indexes speeds up performance significantly when joining large data sets together, especially to index polygon features whenever joining something like wells to a leases layer that you might be dealing with. To spatially index that lease layer makes the join happen a lot faster. So at Jonah, we use large data sets in the sense that they will be sometimes, dozens of gigs, maybe less than that, but definitely over 10 gigs. But it's not technically big data, right? Some people come from the big data world where you're dealing with terabytes or billions of rows as opposed to millions. So our needs were best handled by the pretty much boilerplate spatial join and constraint logic that you see on the right. I've replaced one of our typical tables with a generic company one table, but in order to spatial index, you have to add a constraint on a unique identifier field. For in this case, it's an object ID, which for my GIS people should be familiar. It is Esri's unique identifier field. And then we create a spatial index on the shape field. And we don't have to necessarily set too specific of bounding boxes to correspond to a perfect fit for our data, since we're not dealing with two huge data sets. And we do this. We have to add these constraints and add these spatial indexes onto our temp tables because you can't alter the tables directly in an ArcSDE environment. You have to select them into a temp table, alter them there, index them there, and then do your joins, your resulting joins on whatever point or line feature classes that you want to after that. So I want to get into about Jonah a little bit and how we use this technology. Real simply, we're an upstream E&P company headquartered in Denver. Field office is in Pinedale, Wyoming, which it's real beautiful up there. It's right in the Wind River Range, just about an hour and a half south of Jackson. And we have roughly 2,400 wells, which lends itself to a ton of data coming in, whether it's production data, leasehold data attached to those wells, dedication data, everything. So we are dealing with a good amount of data that we handle using SQL Spatial. So whenever I came into the company or came into the industry, some of the traditional GIS that I started with was GIS was siloed inside of different departments. So the land department had their own mapping technician. Geology had geotechs that didn't touch GIS. Operations and field GIS had their own GIS people in the field doing mapping or doing surveying. But at Jonah, GIS is located in the IT department. So, it's not on. Sorry about that. GIS is inside the, whoa, I'm not touching that. All right, let's see if it holds steady. GIS is inside of the IT department and handles all of the departments across Jonah. And I love being a part of the IT department because it allows for more collaboration with our data ops team, our data management and analytics team, and our system solutions team. We can kind of keep an ear to the ground of what's going on, what new development is happening, what new applications we're getting, how the backend works, what's coming into our data warehouse, the schedule that it all happens on. It really allows us to be more creative with our solutions. It's kind of fun to hear some people talk about things and be like, oh, I can map that. Like, let's talk and let's collaborate and see what we can do. And that's obviously not unique to Jonah, but I think more companies are trending in that direction. So at Jonah, we have two types of data, and this is going to be pretty key to the rest of the talk, is to remember that we have data warehouse generated data, which data needs to be updated every day. Think wells or production data or line pressure data, and we use SQL Spatial to process all that. The other type of data is user generated data, which is flow lines, least polygons, basically something that would be considered traditional GIS, where you have an analyst going in there and digitizing a new flow line that someone just mapped, or we picked up a new lease and this is a legal description and it's just on a piece of paper and you need to digitize it for us. So two types of data warehouse, and user generated. So the way we used to roll with our GIS technical architecture is like this. We have all of our traditional upstream oil and gas platforms. Some of you might be very familiar with all these. We have these and more, and these feed into our data warehouse, and our DM&A team is great. They do a lot of great work with running our data warehouse. So we would grab all of the data that we need to generate every night using Esri Python processing. And we basically use tools like create features, select, calculate fields, add fields, all using Esri's Python libraries, ArcPy, dealing with Python 2 or the ArcGIS API, dealing with Python 3. But it was basically just a convoluted way to write a bunch of SQL, we found out. Obviously, you can create new tables, you can join tables, you can calculate new fields, add new fields, all in SQL without having to be connected to a computer that has an Esri license with the ArcPy library installed. You can basically just spin up SSMS and calculate stuff that way. So after we would have that Esri Python processing, we put it into our master database where it would live alongside our user-generated data sets. So those two types of data that I was mentioning, they both live in this master DB. We would then copy those features every night from master to dev to test to prod. There was like 250 feature classes, so it took forever and it failed all the time, and it was just not an efficient way to do it. And the worst part about it was the end users in the top right of this diagram, they would be connected to our ArcGIS portal web apps, which cause schema locks on the production DB. So if we wanted to edit anything or upload anything or fix the jobs that didn't run last night, we had to wait till the next night until everyone was disconnected, or experience a downtime in web maps and shut the whole system down so we could run these processes. As I was just talking about, users waiting for the overnight jobs to run to see changes reflected is probably the biggest issue, since those production layers are schema locked and users are viewing web maps throughout the day. It created an issue for a lot of users because they would use their web maps all the time for their own demos and make their own maps. And if they would call me up and say, hey, I just got this CSV of this pipeline I want to look at. Can you digitize it and put it into a web map so I can show my boss about a pipeline I need to build? I would say, no, I'll get it in there tomorrow. Whereas nowadays, the way we handle it now through SQL Spatial and through replica data sets, we're able to avoid schema locks and update data on the fly. And the last issue is the no real time capabilities. So with SQL Spatial, using some solutions that I'm going to show in a bit, you can view live data on whatever frequency that you want, whether it be an hour or 15 minutes or every minute. You can view that real-time data without getting into schema locks and pushing new data to your production GIS databases. So the solution we came up with, as I explained a little bit, I'll just briefly go over this. We use SQL Spatial to generate from our data warehouse, writing directly to those ArcSTE databases. And we remove those Esri Python processes. And again, for my GIS people, stuff like make XY event layer, which is just outdated and uses memory, or select by attribute. That's all can be done in SQL pretty much. And for the non-data warehouse, that second type of data, the flow lines that a GIS analyst would create, we utilize replica data sets as opposed to copying over every single feature class every night to all the different servers. So only changes are only synced on data sets that have been altered. So instead of copying over everything all night or everything every night, we use SQL Spatial to generate the stuff from the data warehouse. We use replica data sets to sync changes to our prod DB on the user generated data. So here's how we're working now. Still with all the data warehouse integration, instead of that Esri Python processing, we're using SQL Spatial processing. And we're pushing that into our GIS master and live database. We then split out our SQL generated layers from our user generated layers. Our user generated goes in that replica data set, and our SQL generated layers we rip straight from our GIS master database. And the only difference between how the production database and the user generated layers and SQL generated layers feed our ArcGIS portal web map is that there's a specific set of parameters that need to be set on the ArcGIS server services, which is what that server definition is right here. And I will talk about exactly how to set up something so you have a live data capability. But this ArcGIS server service is literally watching the feature class 24/7, and anytime that updates, it updates and subsequently feeds the portal web app for live data abilities. And it's all due to that service definition, some specific configurations that we have. So for a typical SD to web map process, you have your DBMS, your layers, your typical wells, leases, pipeline, roads as an example. You have your GIS GUI, whether ArcMap or ArcGIS Pro, and then you publish that directly to ArcGIS server, which then feeds portal, aka web maps for us. And in order to enable SQL Spatial on some of these SDE databases, you need to configure your feature classes to act a certain way, and you need to configure the settings and parameters of the service definition whenever you publish from the database to your server. So for the feature class design, you need to create a new feature class, and this should be very familiar to some people if you're deep in the Esri environment. When you create a new feature class, you pick your lines, polygons, or points, whichever you want to use, and you pick your coordinate system, which must be in the same coordinate system that you're doing your calculations on in SQL Spatial. So we've been in NAT83 the entire time I've been talking, so we're going to stick with NAT83. That's what we use for all of our SQL Spatial calculations. Then the final configuration for the feature class was something that opened a lot of doors for us once we realized. I think I read a blog post from like 2012, which was amazing that it was still around, but it tipped me off to this trick where you do not use your default configuration keyword, use the configuration keyword of geometry. And on that dropdown is also geography, like I was explaining earlier. So if you wanted to have like a rounded SQL Spatial calculation, you could also do that. But as I was mentioning, we only use geometry. So creating your feature class like that sets you up to basically write out to feature classes in ArcSD directly from your SQL Server Management Studio. The last thing you need to do is you still have to generate object IDs, which is Esri's unique identifier. It must be in every data set. And we achieve it in SQL by just iterating over row numbers, ordering over a certain field. Facility is a field that we use a lot. So that's just an example that I read from one of our scripts. But writing all those row numbers directly to the object ID field will make Esri happy with you and let you do what you're trying to do. And the other part that needs to be configured, the last part, is that service definition that I've been talking about for a while. Traditionally, you publish from ArcMap or ArcGIS Pro through their application, through their software program, right, directly to ArcGIS server. And you're able to change some configuration settings, but the way to get live data that updates in ArcGIS server and ArcGIS portal is to save out a service definition file as opposed to publishing a service. Sorry. There we go. And then setting your connection to no available connection and not including data in your service definition when publishing. This no available connection and not including data will kind of give you a blank slate for your ArcGIS server service, which allows the reading of constantly truncating and appended data from your master database up to the web maps. And lastly, to publish a service, as opposed to just doing it through the GUI like I was talking about, you, in your ArcGIS Service Manager, you publish the service definition where you have your SD file that you just created and you upload it that way. So the live data streams that I've been mentioning is passing data directly from SQL into production GIS tables. As I was saying, they're tied up to ArcGIS services, which feeds our web maps or dashboards. And best part, it does not create schema locks. So you're able to constantly do this throughout the day at scheduled intervals. So some projects that we have at Jonah that we actually utilize SQL Spatial for. First is live field production. We have field meters in the field that that write out to a SQL database, flow rate, casing pressure, line pressure, temperature, kind of your standard wellhead meter, and it gives live insight into well production and line pressure hotspots without the extra license costs. So you don't have to license people to a specific field monitoring software application. We can process that data all in SQL, pushed out through GIS, where we have unlimited licenses based on our enterprise level subscription. The second one I'll talk about and give some examples for later is the depletion model, which we are basically calculating the percentage of depletion in the field based on original gas in place, aka OGIP, as I'll call it from now on, and machine learning driven production calculations. I can't get into typically or specifics on the machine learning driven production calculations, but I do believe I have a white paper that I can share if I get approval for that, if anybody's interested after the presentation. Last one I'll talk about is a spacing calculator. We want to calculate valid spacing positions based on state and federal requirements. You're only allowed to have a certain amount of wells in a certain amount of, or in a certain area to prevent over depletion and waste of the reservoir. And that assists the company in well planning for vertical inventory locations. So as I was talking about the live field production, we have those production meters showing all of those attributes for each well, and allows for that company-wide access like I was talking about. And we have these joins done through SQL integration with those back-end production DBs done every 3 minutes, and data from the field coming in every 15 minutes due to size and transfer speeds. And that's just because we're dealing with data coming in from Pinedale, Wyoming, every second, writing out to a database. So we haven't really found the need for second data or the capability with the internet connection to push out second data all the way to Denver so that then we process it. So 15 minutes has been adequate for what we're doing right now. So I'll get into a demo of the live field production web app, and this is pretty dumbed down for the record. I've had to obviously reduce a lot of the data points, so we're not showing actuals from across the field. So we just have a bunch of dummy data that we're going to show. Looks real pretty. So this right here would be an example of the live field production dashboard, a template of it with a lot less data than we're sorting out to our own customers. So as you can see up here, we're current as of 4-ish p.m. A lot of these are some of them old, but usually within the last 20 to 25 minutes, we're able to get every single well's production in the entire field. Also, what we been able to do is map line pressure across the field. And again, this is all dummy data that I'm pulling in from SQL, but current timestamps are accurate. So we're able to map potential hotspots across the field for line pressure. Let's say there's an entire group of wells that is spiking really high line pressure before they dump into our midstream operators. The automation team can open this, see exactly where all these are without having to view a tabular list of wells and think about, hey, where are those? They can open up this dashboard, find out where the problem area is, and come up with solutions as to why it's happening. And one of the other configurations that you have to make in ArcGIS server or in your portal web map, if you change this refresh interval, and you can change it to every 2 minutes, 1 minute, whatever, if you have the dashboard up, it'll automatically update on the interval that you specified. So you can literally have your ArcGIS web map or dashboard up, and you get a constant stream of data. As soon as it changes and we do a truncated append on our production databases, it shows up in the dashboard. So something that we, or an oil and gas company would use this for is if a company sells its natural gas to two different companies in the field, each with their own pipeline infrastructure, and you have to transfer gas from those sales point to the midstream companies. Problem is company one has a PSI limit of X, two has a PSI limit of Y. So all the wells across the field, if some of them need to be under a certain limit and others need to be under a different limit. And with SQL Spatial and the spatial joins that we're able to do, you can do a live calculation alongside those field meters every 15 minutes to see if we have any issues. So I'll go through a quick code example from like a dumbed down code example from A to Z showing how we do it. So we're selecting our company one table from our ArcSDE database into a temporary table so we can alter it and do a spatial index on it. And once we have that spatial index done, we can join our wells feature class and do an ST intersects, which is basically saying if the wells in our table, if the shape of those wells intersects that polygon of company one, then it's company one. If it doesn't intersect company one, then it's company two. And we can do this because there's really only company one or two. There's no third, or there's no null value that could be had. Again, if we didn't need to set the PSI limit, we can see where the wells intersects company one again, set the PSI limit to X. Again, if it doesn't intersect, set it to Y. So then we can map across the field where we're going to have problem hotspots based on X and Y, since those PSI limits have the potential to be different. Next thing I will talk about how we utilize SQL Spatial is the depletion model. And this was a pretty exciting one because it really directly impacting year-end reserves and how we view the field. So Jonah wanted a better way to predict the hydrocarbon reserves that we had left to find underutilized areas or overexploited areas, to avoid in general. So we had previously developed that machine learning algorithm that I talked about earlier to predict depletion over the field. We're pretty confident in that. So we then combined this with an OGIP measurement, which is original gas in place, as I talked about earlier, from the geology team. So those two measurements were sampled to a grid, and then we need to compare the two on a quarter level in order to find and utilize the underutilized land areas. Excuse me. So in general, the OGIP and the depletion models were delivered to us in the form of a point cloud. So these points were spaced on 40-foot by 40-foot grids, and they each had a value. They were different units of measurement, so we had to convert that, which I'll get into. But in general, we just have a massive amount of points for OGIP and depletion to calculate and join. So the example I'm going to be using is one PLSS section, which is 1 square mile. And a 40-foot by 40-foot grid gives you roughly 17,000 points whenever you're working with it. So it becomes pretty critical very quickly if you think about how many square miles some oil and gas fields are. I know I'm just showing one, but if you're dealing with a 300 square mile gas field, you have a ton of points, and using some of these non-SQL spatial techniques really bogs down your time, and it really just takes forever. So here is the example of a depletion model. So on the left is an example of the original gas in place, green being low projected original gas in place, and pink and white being very high projected OGIP. So you can see on the right our estimated gas extraction. So our idea is to compare these two point grids together and then sum them up by each square that you see here. And we'll get a calculation for each quarter area. I actually have some more SQL to show, kind of basically showing how we did it, which I think is probably the best way to do it, just most interesting, at least it would be for me. Okay, so I'm going to, let's see, where's my mouse? Okay. I'm going to start by selecting, I'm selecting it into a Jonah tables. I have some of that commented out, so we can't obviously see some production stuff from us. But I'm selecting a PLSS quarter grid, which is that square mile that we had, and that I just showed on the PowerPoint presentation, divided up into a 4x4 grid. They're called quarters if you're not familiar with the oil and gas space. But then we're going to do some string logic to kind of get a PLSS key that we can join to basically remove some of the spaces, some of the preceding zeros, some of the trailing zeros, to basically pretty it up so it looks like this. So you get a township and a range and a section and a quarter without any of the extraneous stuff that you don't really need in join. You kind of strip down the PLSS code down to bare bones. So, and as I walk through this, I wrote this about 6 months ago, and I as I was looking at this today, please don't judge me on how inefficient this is. I haven't really opened this up in a while, but to hold all the OGIP calculations, we created a new temp table and selected, got our OGIP calculations into this table, the 40 by 40 foot grid. So the issue we needed to solve was to get these two measurements in the same units of measurement. I actually think I should have shown an extra slide, so I'll just pull this up, but I think I skipped over a little bit too early. But so OGIP is on a 40 by 40 foot grid like we talked about, which occupies an area of 1,600 square feet. If you think about it, right, every single point is going to occupy that space. So the problem is our depletion model is in MCF, and our OGIP is in MMCF, millions of cubic feet per acre. So it's an average already. So in order to get these two in the same units of measurement, we had to multiply OGIP by 1,600 over 43,560, which is the square foot per acre. Then we had to sum each of those results, all of those dots, once we have that, by quarter, which gives us our MMCF value per quarter. Then we multiply it by 1,000 in order to get it from MMCF into MCF. Our result will be raw OGIP summed up per quarter, which will then allow us to compare the OGIP and the depletion MCF values. So with that being said, here is what I just talked about in SQL form. So we're able to, we basically sum up the OGIP multiplied by 1,600 over 43,560, which I just talked about, and then multiply that 1,000 to get it into the same units of measurement, that MCF as opposed to MMCF per acre. So now we're dealing with apples to apples, so we can then compare the two. So here's just some unnecessary stuff that I made that calculates OGIP per acre. Then here's where we add the depletion in. So we are basically adding the depletion, joining it on our quarter shape. So if it's contained in our quarter, we are going to include it in our calculation. And we're going to group that by our quarter PLSS key that we generated above. So each of those 16 squares are going to have its own key, and it's going to grab every single dot that's in that square and sum it up. And so we can compare the two. We can compare the two OGIP to depletion. So the last step is to truncate and append to our database so we can view it. So we're going to generate that object ID, like I mentioned before, that unique identifier that we're going to that Esri needs. And then we're going to do some math right here just to select some different fields that we're interested in, like gas cube per acre, raw OGIP, raw depletion, how much we think, how many MCFs we think are remaining, the percent depleted. So I'm going to run all of this, and let's see. So yeah, it's running now. And in order to do all this, it's going to take, it should be done fairly quickly. There we go. So as you can see, all these rows affected, we're dealing with our quarters and our point grid of about 17,000 different points. And we have our final subsequent rows affected. So I have a live connection to this on another screen, which shows our output of our resulting quarters. And the numbers that you'll see on the screen are a calculation of percent depleted. So for this random example, we're looking at anywhere from 15 or 16% depleted to 26% depleted, and we can plan our existing vertical inventory based on what we know now, or what we think we know about the depletion in the field. And to show you kind of how quick this can update and show you the sweet capabilities of setting up your feature classes to accept spatial SQL inputs, is I'm going to open my SQL back up and mess with the depletion. So right here, this depletion by quarter, the cumulative gas that has been depleted from that, I'm going to multiply that by 2. So what that should do is, where our original gas in place is staying the same, we're basically saying the depletion is multiplied by 2. So we should see all of those squares that I was just showing you double of their percent depleted, since we are increasing depletion, not increasing the original gas in place. So I'll run that one more time. There it goes. It is done. I don't think I closed that. There we go. Okay, so as I move the mouse right here, now you saw it refresh. So this one went from 15 to 31, and the rest of them are in the 50% range, which were in the 25% range before. You go back and you change it back. You don't want to multiply by 2 anymore. You want the actuals. It calculates. You come back, and again, I'll give you a second to adjust. You can see this 31 up here. You move it again. The data has been updated. So all you have to do is refresh the map, open a table, change something, and it's, your data is reflected live. We'll jump back into the PowerPoint. I think I might be done with the SQL code portion. There we go. Oh, yeah. Okay. So our results that I was also just showing you on the page, just a cleaner, nicer example of, so you can compare original OJIP to estimated gas extraction. You can see how valuable this could be whenever planning new well locations for year-end reserves, and seeing how much we really think we can extract economically out of the earth. And obviously, this is not the only factor. If there's no accessible surface drilling locations, you can't get a permit, or you don't have the leasehold. On top of this, it becomes difficult if there are environmental stipulation concerns. Let's say like a endangered bird moves right into a section you're really trying to drill. It's not good for you. And so this isn't the end all be all of exactly, hey, pick a point here. This has underutilized. This is underutilized. There's a lot more that goes into it, but this is definitely a very helpful example of how we do spatial. And the last one I want to talk about is our spacing calculation tool. So for those of you who are not familiar, in order to prevent waste from occurring, these state and federal governments, they limit the number of wells that you can drill in a given area of land. And you are not allowed to go over this limit, and or you have to apply for an exemption in order to drill there. They basically want to prevent waste, so you don't just over drill a reservoir in a certain area. And it's important in the reserve process because we have to calculate the number of wells we can drill based on that land area. So you can't just go to your reserves guys and say, hey, we can drill 24 wells here. Really, you can't. You're only allowed to do 12, no matter how much gas is there. Unless you apply for an exemption, there's only a certain amount of wells you can drill based on a given area. So the geology and res teams base those vertical inventory plans on where they think the gas is. So they don't necessarily know right off the top of their head which areas can hold more vertical inventory versus which areas cannot. So we use SQL Spatial to compare these basically these spacing requirements from our known limits. So we have like an area of land which has max 12 or max 18 wells. And we can do a super quick join of all of our wells that are already there. So we have the data of max, and we can spatially join all of our wells, and boom, it's done super quick. So I had the pleasure of sitting down with one of our reservoir engineers for like 40 hours last year with a paper map, literally going through by hand and like circling dots on a map, counting all this. Last time I'll ever do that, wrote a script to fix it. So it's just done every night in a quick amount of time, and they can rely on that to literally count how many more they can use without, or how many more wells they can drill without having to double or triple check by hand. So here's an example of an output of what our spacing calculator would spit out. So the example I'm showing again is an area of one PLSS section, 1 square mile. These individual red and green rectangles are 80 acres. There's 200, there are basically 2 quarter quarters combined. There's a 200-foot buffer from the edge that you have to keep off of typically or apply for an exemption. So as you can see, we can basically highlight real quick where we have too many wells planned or we don't have enough wells planned. So on the right, you can see we have way too many wells planned. I think this corresponds to the bottom, the one at the bottom left. We're only allowed 12. We have 9 already there, and they want to drill 8 more. Can't do it, obviously. So that is a count of 17. So that allows them to either view this data or us to go back and tell them, hey, you need to cut this by 5. But as another example, we can identify the underutilized spots. So if you have something down here, like in this on the left side, where it's max 12, count 11, we have 10 existing wells, and they have another one planned. That's something we can go back to them and say, hey, you can actually drill 1 more here. So this is a tool that we update every night, like I was saying. We push out through our web maps so people can view spacing calculations, requirements, max and mins, and see what kind of different strategies they can go about whenever we're planning our locations. So that those 3 examples is kind of where the rubber meets the road for Spatial SQL with Jonah. We have a few more examples that I can talk about way too long for, but these are 3 of the pretty high level results where we're actually using this in a production environment on a day-to-day basis to really help benefit the company and benefit us. So we're not spending a ton of time, like I was mentioning, staring at maps, going over with pen and paper and really picking apart certain things. So I guess data driven, right? To wrap it all up. So if anybody would like to ask any specifics, get into any discussions, I am all here.
Thanks. That was great. Anybody that wants to chime in and have a question, please unmute yourself and feel free to speak. Or you can, I was monitoring the chat and I didn't see anything in the chats yet. I will ask you a starting question. If you can talk about how your work in GIS being part of the IT group might have really helped. You mentioned how it helped you see things that could be, where there were opportunities to connect data to the GIS work. Right. Is there anything what's maybe one of the most unexpected places where you've been able to link it to just by virtue of being connected as opposed to being in a specific asset team?
Sure. Yeah, the one thing I'm thinking about is, whenever a well, I would never have known this if it wasn't for me noticing some inconsistencies in other databases. So I work a lot with the data management analytics team, and one thing that was important for us was whenever wells go after they're drilled very recently, they go on flowback, and that data is not integrated into our production right away. So there's a little bit of lag time on where that data lives. It's not totally tied up to a meter yet. So it gets distributed in these Excel spreadsheets every morning whenever we have a well or wells on flowback. So that's very important to the success of the company. You want your new wells to drill well, and the only way they're distributing any of this was through spreadsheets. So I go over to DM&A, which I usually wouldn't even know what flowback is or what they're dealing with. I go, hey, where does this data live? Is it in a SQL database that we can access? So now we are serving this out through our web maps, and any well that's on flowback, you can get a live reading from the meter in our GIS app that I kind of showed a dumbed down version of without having to rely on a spreadsheet in your inbox at 8 a.m. we kind of created some dashboards, both in Power BI and as a web map to help people view data that's actually just critical to the success of the company.
You're on mute.
Are there ways that this is changing the way your field team or anybody, your operations make decisions as far as updating, not just sort of how we normally would like to make a decision and move forward on anything about, say, the flowback, but other new things they're able to look at and new conversations that are happening just because you're having, you have this data available in the spatial format?
The automation team was actually the ones that asked us to develop this line pressure solution that I talked about. They're pretty infamous for dreaming something up, asking for it, and then forgetting about it or not using it. But identifying those line pressure locations is one that they specifically asked us to make. So they're looking at it constantly, and I don't know if I can't tell you that we've saved a line pressure spike or like saved a catastrophe from happening, but the ones who asked us to make it definitely use it.
Looks like Brian posted a question in the chat. Are there other issues to watch for when integrating between Spatial SQL and SDE? We seem to have them butt heads fairly often, especially changing SDE tables via SQL.
So updating those SDE tables via SQL, if you set up your feature classes the way that I kind of described in the previous one of those previous slides by setting the geometry field, I've had no issues updating those SQL tables. The big issue that I've run into is if we have data in a Wyoming West state plane coordinate system versus in NAD83. If anybody knows how to transform between NAD83 and other state plane coordinate systems directly in SQL, let me know, because that's been the biggest thorn in my side is dealing with those coordinate systems, because most of our data lives in Wyoming West, but our SQL spatial data is generated in NAD83. That's pretty much the biggest one. I see some of these questions that I can address.
Yeah, Mark just asked about the past GIS architecture, the current GIS architecture. What's the primary driver for switching to spatial SQL? Cost or workflow efficiency? And then the second part of it is the new workflow cheaper than the old one, and by how much, or by what metric would you say yes?
Sure. New workflow is cheaper because we eliminated an entire test environment for our enterprise GIS subscription. We used to run with a dev, test, and prod environment, all of those hooking up to web maps. And instead of just pushing from dev to test to prod, we remove the test and we just have dev, and we have replica data sets as opposed to pushing that data across. That was the only dollar amount, physical thing we can judge and save. But the big savings came in are the headaches of the overnight jobs. So those jobs taking so long to run and using those Esri Python tools to copy the features over as opposed to just truncating and appending with SQL Spatial. Probably saved man hours the most of our GIS team, not having to deal with the headaches of the jobs taking so long and failing and reconfiguring them. So fiscal costs probably just the man hours that we're dealing with, and maybe cost savings of not having to subscribe to some IoT solutions that are offered out there. So we can just basically read SQL tables and truncate and append as opposed to subscribing to some of that IoT stuff. So we kind of get IoT functionality without subscribing to high dollar subscription services.
I have another question about the 40 by 40 foot grid and generally how you talk about how you use the spatial flag. So you mentioned the spatial flag for inside or outside of a polygon,
Right.
but I presume you could also do it for proximity to a point or line.
Right.
And so I'm wondering if you could talk through a little bit of, have you explored other grid sizes than 40 by 40 foot, or how you arrived at the 40-foot grid? And then for other situations, have you explored other ways of calculating or multiple ways in parallel that lead to new workflows or other ways you're putting this to work because it's now easier to do in SQL?
Right. The 40 by 40 grid was determined that that's all the granularity that they needed at the time, especially with such imagine, I don't know how many sections that we have, but it's way more than one. So they just determined that they just need a 40 by 40 grid for the granularity. We could go lower. To run our whole field takes like less than a minute for that OGIP to depletion. When you saw it to do 16 squares took a matter of 1 or 2 seconds. But I think we could go even more granular if they wanted. But that's kind of how the reserves are calculated, is on the quarter level. So keeping that on the quarter calculations made sense for people who are going to our auditors with the data. But I would like to get even, more granular, just kind of create some cool maps, deal with bigger data. But for now, 40 by 40 was good enough for us. And I don't remember, I think you asked another question, but I didn't.
I was thinking more about different ways of specifying distances between things. So when you spatially, you might say something is within a polygon, but for points and lines, you might care about how close, let's say, how close is a well to a road or a feature, but you could specify that in a couple of different ways. And I wonder if you've started exploring or found curious insights about different parts of the business or multiple parameters that are becoming important for things that you're evaluating now.
We have not had to evaluate proximity to lines for our wells. It's all been to the edge of a polygon. We haven't had a use case yet. I'm all in if we have a use case that people want to start evaluating, but I can't speak to joining proximity lines to polygons.
George Humphreys just asked if the SQL spatial component is outside of the SDE SQL architecture.
In the sense that yes, you can calculate SQL spatial stuff on a non-SDE environment. If you have like I believe there was an example of a post-GIS presentation in October. You don't have to have SDE to do any kind of SQL spatial. You don't have to do anything with Esri. It's just the enterprise environment that we live in. All the calculations that we do in SQL Spatial, we basically start as we have a template of our polygons or our points coming from SDE or the data warehouse, but all of the SQL Spatial that we do happens in SQL. And we don't write out or call back to SDE until the end whenever we're truncating and appending into our production databases for use of the pipeline up to our web apps.
With all the automation or the somewhat automated development planning that you've been able to build with this, are there new things that you're able to, like you're freeing up time to focus on tools or projects that are more in depth than you would otherwise have been able to? Or new ways of ranking the wells that you're dealing with? I know that it seems like there's a lot of opportunities to keep moving forward on the depletion tool that you've built. Don't know how much of that you can speak about, but helping us understand sort of the question about value. There's a time value in being able to now research or make progress in more complicated things. I wonder if you could speak about that.
Sure. The thing that I'll try and keep this as general but detailed as possible. The machine learning predictions that we do the depletion for, and like I said, I think the white paper is public that I could share, but I'll have to check on that. But basically, we use SQL Spatial in that to kind of judge like if two wells are closer together than they are further apart, the depletion impact on both of those wells. If you drill a third right next to it, your well is not going to be as good as if you drill a well 1,000 feet away. So utilizing that, we're able to find areas that are far enough away from other wells to plan locations. That's SQL Spatial is heavily involved in that process, and it's still running today and still drives a lot of our reserves calculations.
That's really helpful. It seems like an area where there's certainly probably lots of proprietary work going on, but I think it's neat to think about or explore how there's ways, once we automate some of these old mechanisms, that give us a chance to start diving deeper into advancements elsewhere.
Right. Yeah, and us
well,
doing that.
If anybody else has a question, please chime in or write it in the comments. I really want to thank Taylor for taking time to put this all together and sharing the work that they're doing at Jonah. We'll have an email coming out shortly about the next couple of talks we have coming up about what Jesse Pissell is doing at Texas and some of the research groups over there, keeping us thinking more about ways to advance some of the workflows and bring in some of these digital tools to help us do better oil and gas work. I don't see anybody else having comments. Really want to thank you, Taylor, for spending time to do this. I know it takes time to put these together. If anybody has talks they'd like to give or people they'd like to see talk or topics they'd like for us to focus on and get more presentations on, please let Mindy or I know. If you'd like to be on the email list and are not, please let us know. We'll get you on there. Otherwise, we'll have an email out and LinkedIn post soon about when the next talk is. I believe it's at the end of this month. I'll send that out, or we'll send it out soon. Thanks, everyone, for joining. Have a great afternoon.
Thanks all.
Thanks.